Hello, everyone, and welcome to the webinar, or I should say, welcome back to our webinars. We've had a little bit of a break, and we'd actually like to get back into the mode of having our weekly webinars. And this week's webinar, what we're going to be doing is actually part one of a two-part series of webinars, and we are going to be discussing automatic feature recognition and machining. Now, what exactly is automatic feature recognition and machining, also known as AFRM? Well, let's actually take a look. Feature recognition is basically a two-part action. What do we want to do, first of all? What we actually want to do is we want to recognize the features themselves. And then the second part is to machine them as well. Now, what kind of features do we exactly recognize at this moment in SolidCAM itself? Well, there are three basic features that we recognize. One, we have a feature recognition for pockets, for recognizing all the pockets. Another one is the chamfers themselves, actually creating chamfers on sharp edges. And another one is holes. Now, today's webinar will be dealing with pocket and chamfer recognition, whereas next week's webinar will be talking about all the different options we have for hole recognitions. And it'll actually be a very interesting one because there's some new features that we have in there which actually also recognize the SolidWorks hole wizard features that are created in SolidWorks itself. But today's webinar will be talking about pocket and chamfer recognition. Now, let's first start off with the pocket recognition. What exactly are we recognizing? What features are we actually recognizing when we talk about pocket recognition? Well, we're talking about features such as open pockets or closed pockets or blind pockets. Those are pockets that have a floor on the bottom, or through pockets as well. But not only do we recognize the pocket, we also recognize the upper face of a part or any kind of stud that may be sticking up. So we also recognize those, and those in those particular cases are always open pockets. So those are the type of pockets that we recognize, and all the pockets are also user editable. In other words, you can edit anything you want within those operations. Now, it's actually a two-part the pocket recognition actually works in two parts. First is the actual recognition itself. We'll recognize the pockets as far as also their upper levels and goes directly to the depth of each individual pocket itself. And then there's the second part where the user has complete control, such as for defining the tools, the type of technology that the user wants to use. That's up to the user itself. And, of course, all the different types of cutting strategies that the user may want to use as well. So let's actually see how this works itself. Let me load the part. Okay. Now, let's take a look first at this part. I'll be doing it on several different parts, but I'm going to start off with this part in itself. In this particular part, we have several different pockets over here. For example, this area itself is considered an open pocket, this one being on the same level as this. This area itself as well is also an open pocket, being on a different level. These slots over here are also open pockets, being even deeper, and you have these open pockets here as well as this area over here. You also have these through pockets as shown over here, as well as these through pockets as shown over there as well. Now, if I were to machine this using our regular pocket operations, I would have to do several different operations, or even profile operations. I would have to do several different operations in order to get all of this in. and I have to do one for this one over here, and I have to do one for this over here, separate one for these slots on the bottom over here, this one's separate, this one's separate. They're all on different levels, as well as this one being a through from this level up top over here, this one being a through from over here together with that one. So we'll have several different operations we have to do if I were to do this in a regular pocket operation. So let's see how we do this exactly with our pocket recognition. Okay, so we'll start with recognition, and we'll go to pocket recognition. Now, choosing the geometry, that's what makes everything extremely simple. By doing so, first of all, I'd like to filter out certain holes. For example, I don't want to take anything that's smaller than this diameter as a geometry. So I'm going to say, okay, anything, I'm going to put my marker over here, any diameter that is less than, now click on this diameter over here, less than whatever that diameter is over there, do not accept that as a geometry. You can see it automatically updated this field as well. Now just click on the part itself, and it builds all of the geometries as shown over here. It recognizes every single face on the part itself. All is fine. Now, if you remember, I also said in the very beginning that this recognizes also the top face to machine that as well. Now, in this particular case, I don't want to include the top face. So if I go into modify, we have a simple option here. It says exclude top faces as shown over here. And that'll automatically take away the top face. Okay. Next, it's working almost exactly like in any pocket operation. I'll choose my tool. In this particular case, it's a large part. I'm going to be using a 25mm end mill. Now, let's take a look at the levels. Note what you don't see in the levels. What you don't see is the depth that the pocket has to go to. That's because the depth is controlled by each individual pocket. Each individual area is controlled by each depth, I should say, is controlled by each pocket itself. So I don't even have to deal with the depth. Technology, well, that's like any other kind of pocket operation I'd like to use. For example, I'd like to use open pocket technology of using this profile strategy and approaching from the outside. Okay? And of course, in our links, we have what kind of ramping I want to do, leads in, leads out, all the different ramping options. Let's just click on Save and Calculate and run our simulation. And let's see what we have up until this point. I'll run my solid verify simulation, and you'll note, let me do it a little slower, sorry about that, and you'll note that it is machining every single pocket to its proper depth, and it's machining where it can. Now, you see it did all these through pockets here as well, this one here as well. But note what it didn't do. It didn't do these slots that were over here. I can just click on over here, show rest material, and you'll see that these are areas that were not machined, as well as these slots over here. Okay, the hole I didn't want to go into. But also note that these pockets over here, these through pockets, these corners over here still have to be machined as well. Okay, so all I have to do in this particular case is just do simple save and copy, choose a different tool, and I'll choose my 6mm end mill over here. And in my technology, just like in any other pocket operation, I just go into rest material and choose the previous end mill that I used over here. And that's it. Save and calculate, simulate, and you'll see in this particular case, it's working exactly where the other tool was not able to work, such as these slots over here, these corners over here. All of this was taken care of with the rest material. Okay, now this was a relatively simple looking part. I'm going to load a different part that's a little more complicated. So we'll go into I'll open up the part as I said, and by the way, I'll come back to this part a little later on because there's some other options I want to show you. But let's start with this next part. Now, this next part is something that's typically seen by people who are doing all different small electronic components. As you can see, there are small pockets over here to different depths. You also have little ledges over here. All of these small areas, these surfaces over here, these surfaces over here, all of this, if you wanted to do this in a regular pocket operation or profile operation, it would take you, first of all, just the chaining itself would take you a long time. And the operation itself is each individual operation by itself. So there's a lot of work that can be done over here. However, we can make it a lot easier by using the pocket recognition. Let me see what I can do about this. By the way, this part is also on the second side as well. So you can see there's a lot of work that has to be done. Right now for this webinar, I'm just going to do on one side over here. Okay, we'll start our operation. We'll go to recognition, pocket recognition, and make sure I'm on the right Mac position over here. Okay. And we'll choose our geometry. In this particular case, all I'm going to do is just click on the part itself. No filters or anything, and it's actually recognizing now the entire part as shown over here. Everything has been picked up on the part itself. Okay, again, since I do not want to do the top surface, I'll just go into modify and say exclude top faces. Next, we'll choose my tool. In this particular case, I'll be using a 6mm emerald to start off with. Okay? The rest is just like I did before. Note, there are no lower levels. My technology, if I have open pockets, use that kind of technology. All my link options, all of this is all available over here. Let's take a look at the simulation. And again, you can see it's machining all of the areas that I wanted it to machine. But obviously, the areas where this tool is too large to go into, it will not work in those areas, as shown over here. Okay? You can see there's a lot of areas in this area, this part over here, that was still not machined because this particular tool was not able to enter those areas itself. But you'll note also where it did work, it picked up those edges over there, as shown over here, the different levels. All of this was automatically picked up. Okay. To continue, I'm just going to do save and copy. Choose my next tool. Now my next tool is going to be a 3mm end mill. My technology will use the option of rest. Now this 3mm end mill, by the way, is still not small enough to get to all the areas, but I still want to work it down step by step. I don't want to go directly with a 2mm end mill, so I first stepped it down to a 3mm end mill. Okay, 3mm, previous diameter was 6. Save and calculate. Run my simulation again. And this time you'll see it's working in those other areas where the previous tool could not get into, as shown over here. Okay, but there are still areas where this tool cannot get into, such as over here. So we'll continue now with our save and copy again, and I'll just change tools again. This time I'm going to use my 2mm end mill. My technology, I'll just go into my rest, and this time I'll even write in over here. I know it's a 3mm, so I can write 3 as well, as far as my previous tool. Now let's see what this tool did. This tool just completed the areas where the previous tool could not work. Okay, so this is a pretty complex type of part. We have different levels, small pockets, different level surfaces. It works here just as well. I'm going to get back to this part again in a few moments, but now let me go to my next part. Now, what I'd like to demonstrate in my next part, as soon as I load it, is how we work with parts where the floor has fillets on the part itself. Okay, so I have a simple part, so we can see this very easily. And if we take a look at this part, you'll note the following. We have an open pocket here, closed pocket, open over here as well. But note the floors of each of those pockets. Each one of those pockets has a floor where you have a fillet on the floor itself. In fact, not only do you have a fillet on these floors, but they are of different values as well. For example, this fillet over here is a 3mm fillet. This one over here is a 2mm fillet. This one over here is a 1mm fillet. So you'll have different fillets on this part. So let's first take a look at how we deal with this using the pocket recognition. Okay, we'll start our operation of recognition, pocket recognition. And again, we'll just define our geometry. Now, in this particular case, I don't want to do any area, any hole that's smaller than, say, that over there. Okay? You see it put the value in there again automatically. Click on the part. And it picked up all the areas. Continue. Now, in our modify, again, I'm going to get rid of the exclude top faces, but I want you to note something else. We have here an option that deals with fillets, and it's called divide floor fillets by steps. Okay? I'm going to get back into here in a few moments, but just remember that this does exist. So it recognizes the fillets. How it works on those fillets, we'll see in a moment. Now, the tool in this particular case, I want to start off doing all my rough cuts with a regular 12mm end mill with no radius at the bottom at all. In other words, with sharp corners, a tool that has sharp corners on it. Okay, we have our levels, not touching anything there, open pockets, whichever way I want to work, save and calculate, and let's run our simulation. We'll run it using Solid Verify, and you'll note it worked on all of the pockets where I wanted to work, but note something very interesting. Each pocket that had a radius at the very floor, the tool created a step, leaving material for the radius itself. Remember, this is a tool that has a sharp corner at the very bottom. It did a step over there, as well as one over here, as well as one over here. Now, to be very honest with you, when I do these kind of steps, especially with large steps, I'd like to have more than one step. I'd like to have several small steps over here, this way leaving less material for the radius of the tool to remove. Okay? Because it's not always good to leave a lot of material for those type of tools. So let's go back into our operation, and we'll go back to our geometry modify. Now, I had mentioned a couple moments ago that we have here divide floor fillets by steps, and it did it in one step. So all of them have one steps. But we have a little more control with our steps than what's actually listed over there. If I were to go and click on number of steps, you'll note the first thing over here at the very top. It recognizes that the maximum fillet radius is 3mm. And it put a value of any radius that's between 0 and 3, which basically all of the floor radiuses, do it all in one step. Okay, now, I want to actually break this down into different groups because we have more than just one radius. So note, if I go down to my next line, I can actually open this up over here. When I click on it, look what happens over here. I'll click on it. It'll automatically take my minimum radius at 0 and my maximum radius to 1.5. And then from 1.5 to 3. In other words, I have it broken down to 2, and it broke it down the way I have it. If I were to change my maximum radius to, say, 1.1, note my minimum radius for my next level will be 1.1 to 3. Okay? Now, I can go even further down. Let's go further down. And you can see that it went another step. And it broke this down the way it wanted it to over here. So in other words, I can go up to 4 times, and I can have different amount of steps for different radiuses. Now, I can make changes here that I want. For example, I want my small radius to have 2 steps. anything that's up to between 1 and 2 millimeters, I want it to have 3 steps on it. Anything that's above that, up into my 3 millimeter, I want it to have 4 steps on it. Let's see exactly what the results is after I do my calculation. Taking a look at this Solid Verify simulation, let's take a close look at the steps themselves. Take a look at the 3 millimeter radius. You'll see that over here, we now have 1, 2, 3, 4 steps were created. Okay? If I were to zoom out and go to where I have my 2 millimeter radius, you'll note that we have 1, 2, 3 steps. And over here we have my 1 millimeter radius. You see we have 2 steps. No, we have complete control of our steps. Now, what about finishing the radiuses? How can we do that using the pocket recognition? Well, let's first do save and copy to create a new operation. And let's go into modify. Now, in modifying this particular case, first of all, I only want to work right now on these 2 surfaces over here. So let me get rid of all of the surface by clicking on this check mark over here, as it got rid of the using of all of those surfaces. And all I want to do is use this first surface over here and this second surface over there. Now, besides that, I also want to go into this over here, and I say I want you to ignore the floor fillets. By doing that, it's going to treat it as if it's a sharp corner, and the radius of the tool, it's what's going to create the radius over there now. I'll do that, and I'm going to change my tool. The tool that I'm going to use is going to have a 3 millimeter radius in the corner. And if I go into my technology, I want to work around the profile of that only. Okay? So we'll use the option of rest material. And I'm going to say, okay, where the previous tool diameter, which was my 12 millimeter, I want you to work around the profile of those areas over there. Okay? Now, let's see exactly what happens. If I were to use Solid Verify, you'll see, I'll do this a little step at a time first. You see it's working around the profile itself, of the part itself. It's going to do it on both sides. And you'll note that it only worked on those 2 surfaces, and it did the exact radius that I wanted it because I used the proper tool for that particular area. Now, I want to work on these 2 areas over here as well. So I'm going to do a quick save and copy. Go back to modify. I'll get rid of what I have over here. And then I'm going to use the following: this surface and that surface. Change my tool now to a 2 millimeter radius in the corner. We have one over here, an 8 millimeter radius with an 8 millimeter end mill with 2 millimeter radius, bullnose tool. Leave it, save and calculate. Run my simulation on here as well. And as you can see, it worked on both of those areas around the wall itself, giving the exact radius that I need for that corner. Now, for the last one, the exact same thing. Save and copy. Modify my geometry. This time I'm going to use the last 2 faces. 1, 2. The tool. This time I'm going to use my 1 millimeter radius end mill. Save and calculate. Simulate. And we have it done for these as well, as shown over here. Okay? Whoops, I took the wrong one. I have to add these 2 as well. No problem. And just go back in here. Geometry. Modify, and we want this and this. Just a moment. Sorry. That one and that one. Okay. Save and calculate, run my simulation, and you can see it did those areas as well. Okay. Next, we'll get back. Actually, I want to load now one more part on the pocket recognition, and then we're going to go into the chamfer recognition. Okay, so the next part I want to load is my multi-sided part. And this part, actually, I specifically took a multi-sided part to show how we work on it with multi-sides and specific faces as well. And I left the operations in on purpose, the ones I did with the regular profile and pocket operation. Now, these operations from this point up until here is doing all of my profile and pocket operations. Okay? And you'll note we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 different operations that did all of that. Let's take a look exactly what the simulation shows us over here. And you can see that it machines out all of the areas. But this was done manually. What I mean by manually, that every single pocket, every single profile that had to be machined was done in individual operations, and I had to create chains for each and every one of them. Okay, so now what I'm going to do is I'm going to take these and suppress them as if they don't exist. And I'm going to actually start a new profile, pocket recognition operation. So we'll go into recognition, pocket recognition. Now in this particular case, since I have many different positions over here, I want to choose the correct one. And if I'm not sure which one I need, I can always go into my coordinate system as shown over here, and I can actually see which one I want. Okay? In this particular case, I want to start off with position 1. Okay? Now, let's create our geometry. Our geometry, let's see. We'll do everything. Nothing that's smaller than that radius over there. And we'll just click on the part itself. Again, just like before, in my modify, I don't want my top surface. My end mill, going to be a 20 millimeter end mill. And in my technology, I'm just going to fool around with my open use approach from the outside and use profile strategy. Anything I want over here as well. Run my simulation. And you see, in one operation, I did everything from the top view that was done before in several different operations. Okay, now, I want to continue and work now on the sides. So what I'm going to do is do a simple save and copy. And I'm going to create a new geometry. This time I'm going to use Mac 1 position 2 on this side. This time, however, instead of choosing the entire model, because I only need to work on one face over here. I don't need to work over here. Okay? So I can choose, instead of solid bodies, I'm going to choose faces. And I'm just going to work on this face. Okay? By doing so, it also recognizes automatically which sides are open, which sides are closed, and it also knows the depth. All I'm going to do now is save and calculate, run my simulation again over here, and it did exactly what I wanted it to do. Do it for the third side, not a problem. Mac 1 position 3. Let's flip the part around. Click on the proper surface I need to click on. Made a mistake. Let's clear it all. Unselect all. I need to choose just the face itself. Just this face. Save and calculate. Run my simulation. It has all the settings from the previous operations. And it's all done. Now, what about the rest material? Not a problem at all. Let's just do save and copy. Okay. We will change our tool. And I'm going to change it to a 10 millimeter end mill. Technology, rest material, my previous tool, sorry, rest material, there we go. My previous tool is that 20 millimeter end mill as shown over there. And as you can see over here, it's working exactly just in those corners over there. Continue now for the other side. Again, just save and copy. I'm not even going to change the tool. All I'm going to do is go into Mac 1 position 2, choose the geometry that's already there, and that's it. Simulate. You can see it worked in that area over there. Solid verify. It worked in those areas over there. And the same thing would be for the first side. Save and copy. Mac 1 position 1. The geometry I need for it. If I want to use a larger tool, I can. I'll just change the tool to in this particular case, I'm going to use a 12 millimeter end mill. Save and calculate. Run my simulation. Again, run my solid verify simulation. And you can see it picked up all the rest of the corners that had to be machined. Okay. Now that we did the pocket recognition, let's go and talk a little bit about our second option that we want to talk about today. And that is, just a moment, chamfer recognition. Okay. Now, what exactly are we doing in chamfer? What's our target? Our target basically is to create a deburring toolpath for sharp edges. Today, no one really likes to take their parts off of the machine without taking off the sharp edges. You want to do it directly on the machine. First of all, it comes out a lot neater. And second of all, you don't cut your hands as you're taking your part off the machine. Okay? So what we're doing here actually is we're recognizing all of the sharp edges on the part itself. AFRM captures all of this. The user just can set his chamfer depth, how large he wants that chamfer to actually be. He can choose exactly what's the cutting diameter of the tool that he's going to use. You'll see what I mean in a moment. And you can use what they call a safety offset. Now, what is a safety offset? If you'll note in these corners over here, we have a wall. The safety offset automatically controls that the tool will not come close to that wall itself, thereby gouging that wall. It'll actually prevent gouging from areas such as this, areas such as this over here. You can see all of these areas over here is prevented by this option for safety distance from the wall itself. Let's see exactly now how this works. I'm going to load my next part. And actually, I'm just coming back to the first part that we had on our screen before. The very first part we worked on. Okay? Now, we did all our pocket recognitions. I want to do chamfers on it. Put a chamfer on each one of those edges over there. Okay. Recognition. Chamfer recognition. And choosing the geometry is the exact same way as choosing a geometry in pocket recognition. Again, if there are any diameters I don't want it to pick up, such as this one over here, it won't pick that up. Click on the part. It recognizes now all of the edges that are there, every single one of the edges that are on the part itself. You can see it being picked up as shown over there. All of them are automatically recognized. Simple as that. Imagine trying to do this on a regular operation. You'd have to have chamfers for every single one of them. We'll see. We'll continue on now with the part itself. I'm going to choose a tool, a chamfer mill that's 6 millimeters in diameter. And in my levels area, all I have to tell it is what's the depth of the chamfer that I want. In this particular case, I'll make it a 1 millimeter chamfer so we can see this actually a lot clearer in our on the part itself. In my technology, I decide what's the cutting diameter of the tool that I want to use. Let's leave it at, I'm going to make this actually 2 millimeter cutting diameter of the tool itself. And we have it, like I said before, our safety offset. This is what actually controls how far away we want our tool to be from those walls as shown over there. I'm going to set it actually at 0.5 millimeters, a half millimeter away from those walls itself. Okay? Let's take a look at the simulation. We use Solid Verify simulation for that. And you can see it's creating a chamfer on all of the areas. Now I want to specifically take into account these areas as shown over here. It'll come around in a moment to those areas as well. And note that all of these areas, for instance, this area over here, you'll note this wall was not touched. It was actually had the safety distance that actually took care of that. As well as these areas over here, it was able to do, and no more than that. And you can see that as well over here, in these areas. So that's what the safety feature does. Now, if I didn't have this, I'd have to go define each geometry, shorten the geometry. It would be a lot of work for me to do this on this part itself. This is a relatively simple part. Okay, now let's actually take a look at the different part that I'm going to load now. And some of you already may have guessed it, but the part that I'm going to load now is that little small electronic box that I had on the screen before. Okay, now I want to actually remove the burrs on these parts itself. Okay? We'll do it the exact same way. We'll go into recognition. Okay, chamfer recognition. We're going to choose our geometry the exact same way I did it on the actual, the same way we did it on the pocket operation, choosing it the exact same way, the pocket recognition. We'll choose our end mill. In this particular case, I have a 3 millimeter chamfer mill. Now note that what we also have to take into account is there's very little area between this wall and this wall over here. Okay, so total, the distance is extremely small. If I remember before, it was like a half a millimeter. I don't remember exactly. But if I were to go into my levels, I'm going to have this chamfer depth at 0.1 millimeters. In my technology, my cutting diameter, I'm going to have it so it stays far away as possible from the wall itself. I'm going to have my cutting diameter set at 2.5 millimeters. Okay, or even 2.6 millimeters. My safety distance, I'm going to have it pretty close, 0.2 millimeters. Let's see what this actually does now. We'll run our simulation. We can see the toolpath actually going around in all of the areas, but let me actually do it now using Solid Verify. And we can see that a little better. You'll note that it worked on every single one of those edges as shown over there. Picking them up. Areas where it could not get too close, it did not work over there. Everything was picked up. Okay. Now, from the last part that I want to show is the actual multi-sided part. Because over there, in that particular part, when I do the recognition, when I do it on the sides, I don't have to do it on the entire part because parts of it were done already. Let's actually load the part itself. Okay. Now, these are the parts, these are operations that I blocked out before. Now let's go down to the bottom. At the very bottom over here, I've created actually, before we had the option of recognizing the chamfers, we had to do it in profile operations to do this area over here. And these areas on the bottom over there. All of these had to be done. Okay? Now, when I did this, in order for me to do correctly, I would have to choose my geometry individually, as shown over here, individual geometry as shown over here. Okay? In this particular case, two different geometries. I would have to make sure that it would not go towards the end over here, because the geometry does. So I have to go, okay, I choose my tool, my levels, and I have to pick up my proper levels over here. In my technology, I would have to edit my geometry. And I'd have to say, okay, my start on the first chain, move it out a little, move it in a minus direction at the end of it, so it doesn't go all the way to the end over there. All of this I would have to do manually in order to prevent it from going towards the wall over there. And that's how I'd have to do it for every single one of those operations. What I did now instead was to use the option of chamfer recognition on this as well. Now, I'll suppress these, and we'll start our operation by going into recognition, chamfer recognition, Mach 1 position 1. In this particular case, that's where I want to start off. And in this particular case, I want to take the entire part, and I don't want to do anything that's small, any radius, any diameter that's smaller than that diameter over there. Okay, I'll click on the part itself. The tool that I'm going to use will be my chamfer mill. Just like before. Sorry, wrong tool. Chamfer mill, I said. Levels, I want to have a 1 millimeter so you can actually see it. Technology, cutting diameter, all of this is over here. Save and calculate. Run my simulation using Solid Verify. And you'd see it did all of the edges, and again, automatically staying away from those walls over there. Okay, now next, however, I want to do the side. Now, when I do the side, I don't have to take the entire part. So we'll do save and copy. We'll change this to Mach 1 position 2. And this time when we choose our geometry, instead of taking the entire face, the entire model, I'm just going to take a specific face. I'm going to take this face over here and this face over there. That's it. I'll leave everything else exactly the way it is. Save and calculate, run my simulation. And you can see it did every single one of those edges, and that's all there was to it. And this is the way I would do it for the third side as well. Okay. Let me see if there are any questions. Okay, I see there's a question here. Does AFRM work if there is a corner fillet between the walls and the floor? Well, does it work if you have a tool with a corner radius? I think I showed exactly how it worked over there. You probably asked the question before I actually showed it over there, how I actually did it with the corner radius at the floor. If you have a wall radius, it works just like a regular end mill on the wall itself. And the floor radius, it works exactly the way I showed it. You have to, let me just load the part itself just to make sure we're on the same page. If I go into the part itself, I believe that was this part itself. And let me just open up this particular operation. Now, going around the walls itself, first of all, as you can see, there's a radius over here and there's a radius over here as well. Okay? The way this radius was done, I believe it's this one over here, yes. Remember, in the modify, I just said ignore the floor fillets, and then I used the proper end mill for this particular floor. And it worked on these areas over here. Okay. Okay. I'd like to thank everyone for joining the webinar. Next week's webinar, we're going to be discussing draw recognition, and then we're going to be discussing hole recognition, where it actually builds your technology for you as well. And we'll also be showing you our machining process, but something brand new in our machining process. In our machining process today, we also we're able to recognize the hole wizard features to give us information for drilling holes itself. Hole wizard features that are created in SolidWorks. We have all the information for there, and we can use that to create a lot of our operations very easily, including tools and everything like that. But that's going to be in our next week's webinar. Again, this webinar has been recorded. You'll be able to see it on our site tomorrow, as well as the parts will be available there as well. Okay, thank you for joining the webinar, and see you in our next webinar.